Hello, this is MEI, Further Maths Core Pure. We're in the fourth Matrices section and on the third and final video on three simultaneous equations without a unique solution. You can watch the video straight through, but you will probably find it helpful sometimes to pause the video and try things out for yourself before continuing to watch. In the last video, we looked at solving simultaneous equations in 3 dimensions where there was a unique solution, and we looked at how the 3 planes fit together in 3 dimensions. Sometimes, though, the simultaneous equations will not have a unique solution, and the planes will be arranged in different ways. There are 5 possibilities for how 3 distinct planes can be arranged. Pause the video while you see if you can work out all 5 arrangements. OK, we'll look at these 5 arrangements as we work through the video. First of all, it's worth noting that if M is the zero matrix, then all points are mapped to the origin and there is no solution to any set of equations. As we discovered in the last video, as long as the determinant of M is non-zero, so that M is non-singular and has an inverse, then we can find a unique solution to our set of simultaneous equations. The 3 planes have a single common point. If the determinant of the matrix is 0, however, there isn't a unique solution, because M is singular and we don't have any inverses. It may be that instead of there being one solution, there are infinitely many solutions. In this case, the equations are consistent with each other. If the planes are distinct, then they will share a line of common points and form what is called a sheaf, as illustrated here. Note that for AS Further Maths, you do not need to be able to work out the line of intersection. Alternatively, if the determinant of M is 0, there may not be any solutions at all. The equations are inconsistent. And there are 3 distinct ways that the planes may be arranged. It may be that all 3 planes are parallel and distinct, like this. It may be that 2 of the planes are parallel and distinct, and they are crossed by the 3rd plane. In this case, there is no point where all 3 equations are satisfied. And finally, the 3 planes may form a triangular prism. And again, there are no points where all 3 planes intersect. You need to be able to distinguish between these cases. If the planes are parallel, then they have the same normal direction, and that means they will have the same x, y and z coefficients, or multiples of them. It's very simple to check whether you've got parallel planes or not. If you've ruled out the possibility of parallel planes, then either it's a sheaf, if the equations are consistent, in which case you have an infinite number of solutions, or it's a prism, because the equations are inconsistent and give no solutions. There are more notes on integral or in your textbook on 3 simultaneous equations without a unique solution. That's the end of this short video and the end of this section.